Good day everyone. In today's video, we are going to attempt to find the derivative of polynomials and reciprocal functions. And before we do that, if you have not seen my video on power rule, the use of power rule for finding the derivatives of functions, I will advise that you click on the link in the description below. But before we proceed to the first example in today's class, I will want us to address the derivative of a constant function. And here's a constant function on the screen. F of x is equals to c. What this means is that regardless of the value that x takes, regardless of the input that this function takes, the output remains the same. Constant c. Now, mathematically, I'm going to prove to you that there is an x variable besides c. And let's see how that happens. C multiplied by 1 is c, so I'm not changing anything here. And if you remember our law of indices, x raised to power 0 is equals to 1. So we are going to replace 1 with x raised to power 0. Okay, here we have it. Good. So our f of x, which is equals to c now, is now f of x is equals to c multiplied by x raised to power 0. Now let's use our power rule. Recall that the power rule, if you have a power function and you want to find the derivative of this function using the power rule, you're going to bring down the power, which is n. You have your x, then you decrease the power by 1. Alright, so let's do that here now. So f prime of x now, okay, so we are going to bring down the 0, which is the power, then we reduce the power by 1. And because of the 0 at the center here, c multiplied by 0 multiplied by x raised to the power negative 1, everything is going to give us 0. So the derivative of a constant function is actually 0. So let's take the first example. Here is our first example. We are going to find the derivative of w with respect to z. What exactly we are going to do is to find the derivative of each term. So let's have it w prime, that's the derivative of w with respect to z. So considering the first term here, so the power is 7. So we're going to bring down 7. So 7 we multiply 3. Okay, we have our z here. Then we will reduce that power by 1. Then we'll proceed to the second term. We have 7 here already, but the power is 3. So we'll bring down 3, and 3 we multiply 7. Okay, then we are going to reduce this 3 by 1. We proceed to the third term. The power is 2. We're going to bring down 2. Okay, we multiply by 21, and we're going to reduce the power by 1. And we end up having 7 times 3, 21 z. 7 negative 1, that is 6. Negative 3 times 7, 21 z. 3 negative 1, we have 2. Plus 2 times 21, 42. And we have z. 2 negative 1, we have 1. So our final answer is 21 z raised to power 6 negative 21 z square plus 42 z. Here's our second example where we're going to be differentiating r with respect to s. For the sake of convenience, it is advisable that we rewrite this question. So this becomes r is equals to, let's consider the first term, which is 12 divided by s. So this becomes 12 multiplied by 1 divided by s. For the second term, we have 4 divided by s raised to the power 3. And that becomes 4 multiplied by 1 divided by s raised to the power 3, which also, if you multiply 4 by 1, that gives you 4 divided by s raised to the power 3. So for the third term, we'll leave it the same. That's 1 divided by s raised to the power 4. Okay, so we use the law of indices here. So this becomes 1 divided by s becomes s raised to the power negative 1. We have negative 4 here. 1 divided by s raised to the power 3 becomes s raised to the power negative 3. And 1 divided by s raised to the power 4 becomes s raised to the power negative 4. Now we can differentiate each term with respect to s. Okay, so we have r prime. So let's consider the first term. Negative 1 comes down. Negative 1 multiplied by 12 multiplied by. So we reduce the power by 1. So we have negative 1, negative 1. So let's proceed to the second term. So the power is negative 3. Negative 3 comes down. Multiplied by. We have negative 3 here. Okay, multiply by. So we reduce negative 3 by 1. Negative 3, negative 1. Okay, plus. Alright, so for the third term, we have negative 4 as the power. Negative 4 comes down. Let's put that in bracket. And we have s raised to the power negative 4. We reduce that by 1. Okay, so we have r prime is equals to negative 1 times 12. That becomes negative 12 multiplied by negative 1, negative 1. That gives us negative 2. Alright, so negative 4 multiplied by 3, multiplied by negative 3, that becomes plus 12. Okay, so multiply by s raised to power negative 3, negative 4, negative 3, negative 1, sorry. So this becomes negative 4. Alright, so plus multiply by negative 4, that's going to give us negative 4. So we have multiplied by s, negative 4, negative 1, that's going to give us raised to power negative 5. Okay, so we can still rewrite this as our final answer. So we're going to have r prime is equals to negative 12 multiplied by 1 over s raised to power 2 plus the second term becomes 12 multiplied by 1 over s raised to power 4. Okay, negative 4 multiplied by 1 divided by s raised to power 5. So our final answer r prime becomes negative 12 divided by s squared plus 12 divided by s raised to power 4 negative 4 divided by s raised to power 5. Let's proceed to the third example. In example 3, we are going to differentiate r with respect to s. And the first step we're going to take here is to expand the parentheses. So s here we multiply s here, and that's going to give us s squared. And s here we multiply negative 1 over s. So let's have it negative 1 over s multiplied by s. Alright, so to minimize our confusion, let's just multiply that. Let's just divide this one once and for all. So s, we cancel s, and we'll have negative 1. So let me bring down the s squared is equals to s. Alright, so the s here we multiply 1, and that's going to give us plus s. So that's s times 1, and that's going to give us plus s. Okay, 1 divided by s, we multiply s. Let's have it 1 divided by s multiplied by s. So this we cancel out, s we cancel s. I'm going to have 1 left. Okay, 1 divided by s, we multiply negative 1 over s. Negative 1 over s multiplied by 1 divided by s. And that's going to give us negative 1 divided by s squared. Alright, 1 divided by s, we multiply 1. Let's have it here, 1 divided by s multiplied by 1. So that's going to give us plus 1 divided by s. Alright, so negative 1, positive 1 will give us 0. So these two will go. Negative 1, positive 1 will be out of the equation. So we're going to have r is equals to s squared plus s. So we're going to rewrite this to be negative s raised to power negative 2. And we're going to have 1 over s to be s raised to power negative 1. Now we can conveniently differentiate r with respect to s. So we have r prime is equals to, so for s squared, 2 will come down, 2 is the power, 2 goes down, alright, and we reduce the power by 1 to negative 1 plus. Now for s, the power here is 1. Alright, so if we bring down 1, 1 multiplied by s, so we reduce the power by 1, 1 negative 1. We have s negative. Then for s raised to power negative 2, negative 2 is the power, so negative 2 comes down. So let's put this in parentheses. Then we have s raised to power negative 2, we reduce that by 1. Then the next term is negative 1. So negative 1 comes down, s raised to power negative 1 is the next term. Negative 1 comes down, we put that in parentheses. Then we have s raised to power negative 1, then we reduce that by 1. Alright, so we have r prime is equals to 2s, 2 negative 1, that's 1, plus 1 times s, 1 negative 1, that's 0. Then we have negative 1, negative times negative 2, and that's going to give us plus 2. S, negative 2, negative 1, which is the power here, that's going to give us negative 3. Then plus times negative 1, that's going to give us negative 1 multiplied by s raised to power negative 1, negative 1, that's going to give us negative 2. Alright, so we have r prime is equals to 2s plus 1, because s raised to power 0 is 1, so 1 times 1 is 1. Then plus 2 multiplied by 1 over s raised to power 3, negative 1 times s raised to power negative 2 is s raised to power negative 2, and s raised to power negative 2 is actually 1 over s squared. So we can rewrite the final answer as this. So r prime is equals to 2s plus 1 plus 2 divided by s raised to power 3 negative 1 divided by s raised to power 2. Thank you so much guys for watching.